Hello class. Today we are going to look at transformations of functions. We learned what functions are, now we're going to be moving them around. What we're going to start out with though are 7 parent functions. Oh, hey, speaking of parents, you want to see a picture of mine? Right here. These are my parents, but that's not the type of parents we're talking about. We're talking about parent functions. So I've got 7 of them, here's 3 of them. Let's take a look and at these graphs. So I'm going to put a table of points for each of these and then graph it on the provided grid. So let's see. F of x is equal to 2. So let's do xy or x f of x. So if x is negative 2, y is going to be 2. If x is 0, y is going to be 2. If x is 2, y is going to be 2. See the pattern? F of x or y is always 2. So it's going to be this horizontal, and let's see, horizontal line at y equals 2. Let's take a look at this next one. F of x equals x. So let's give ourselves an xy table here. And so if x is negative 2, y is negative 2. And if x is 0, y is 0. And if x is 2, y is 2. And that gives us a diagonal line through the origin. Looks something like this. And then we want the absolute value of x. And let's go with that color. So let's do an xy here. So if I have x is negative 2, well, the absolute value of negative 2 is 2. And 0, the absolute value of 0 is 0. And the absolute value of 2 is 2. This actually does have a point. And that's the, where did the other one go? There we go. I'll draw it again. There we go. And it looks like a V. Let's take a look at the next couple. Where's my, there it is. So now we're going to get to f of x is equal to x squared. Where'd my pen go? Oh, there it is down there. All right, I want to do an xy table. And let's do maybe a couple more. Let's do negative 2. Negative 2 squared is 4. Negative 1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. And this is one of those, it's a parabola or quadratic. It's a little more difficult for me to draw it on the computer, and I just lost it. Something like that. The function f of x is equal to the square root of x. Let's get our xy table. Let's go negative 2, negative 1, 0, 1, and 2. Well, the square root of negative 2 is not real. So we can't put it on the graph. The square root of negative 1 is not real either, so we're not going to put that on the graph. 0, the square root of 0 is 0. The square root of 1 is 1. The square root of 2 is 1.414. What about the square root of 4? That would be 2. So we're going to have a graph that looks something, it's just a curve. It looks like a half a parabola on its side. All right, let's go to the next. Okay. Number 6, we're going to look at f of x is equal to x cubed. So we'll need our little thing here. Let's go negative 2, negative 1, 0, 1, and 2. The cube of negative 2 is negative 8. Negative 1 cubed is negative 1. 0 cubed is 0. 1 cubed is 1. And 2 cubed is 8. So we've got negative 2 up here at 8. And it's going to come down like this. I did that wrong. Let's erase that. Because -8 is in the, this is going to be down here in the third quadrant. Come through here and come up like that. So that's our cubed root function. And then that's our cubed function. This is the cube. And this is going to be the cube root function. So let's do an XY table here. And I'm going to pick perfect cubes. -8, -1, 0, 1, and 8. Because the cube root of -8 is -2. Cube root of -1 is -1. Cube root of 0 is 0. The cube root of 1 is 1. And the cube of 8 is 2. So at -8, 2, it's going to come up like this. So let's take a look at what happens when we take a parent function. So this one is my parent. And I've got f of x is equal to x squared. So I have some, I'm going to put some points there. And let's see. Oh, -2, -1, 0, 1, and 2. That gives me 4, 1, 0, 1, and 4. And let's see if I can get this to look really pretty. Well, not really, but close enough. Now we're going to do the parent function, and we're going to transform it this way. We're adding a 3 here. So let's go x, y. And I'm going to use those same points. So -2 squared is 4, but then I'm going to add 3 and I get 7. -1 squared is 1, but I'm going to add 3 and I get 4. 0 squared is 0, add 3 and you get 3. 1 squared is 1, add 3 to get 4. And 2 squared is 4, add 3 and you get 7. So I'm going to start about here and it's going to come up like this. Now I've asked a couple questions here now that you see these, and if you graph them on a graphing calculator, you'd see them much clearer than this one, but you get the idea, I hope. So what's the same? Take a look at those. So they're both quadratics, right? And they have the same shape. They both go up. And their domain is the same. It goes on forever and ever. So, and basically they have the same shape. So what's different? The real big difference is in the equation that I circled is +3. That +3 shifts the whole graph up 3 units. As if we're taking that whole parabola and it's going doop, 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 up 3. Let's do another transformation. We're going to start with that same parent function. And something like that. And this time I have a +3, but that's inside this parentheses. So let's see what happens when we do an x plus y, or an xy table. And if we want the same points, -2, -1, 0, 1, and 2. So -2 plus 3 is -1. And when we square that, it's 1. -1 plus 3 is 2, and when we square that, it's 4. 0 plus 3 is 3, and when we square that, that's 9. 1 plus 3 is 4, squared is 16. 2 plus 3 squared is going to be 25. So I'm going to have negative 2, 1. Maybe I should put in some others, because it doesn't look quite like I'm ready to graph this. Negative 3 plus 3 is 0. 0 squared is 0. What about negative 4? Negative 4 plus 3 is 1, and 1 squared is 1. So I am going to have it be about like this. So what's the same? Well, they're both, once again, they're both quadratic. And they have the same shape. And they're both going up. And their domains are both all real numbers. So what's different? Well, what's different is that plus 3 here, which way did we move that? We moved it to the left. So we shifted the graph left 3 units. So what we've done is vertical shifts, those are up and down, and we've done horizontal shifts. So on vertical shifts, if we're given f of x and our transformation g of x is equal to f of x plus a constant, is going to shift up if that constant c is greater than 0, and it's going to shift down if our constant c is less than 0. On our horizontal shifts, let's given the parent function f of x. Our transformed function is going to be f of x plus c. Notice that c is now in the parentheses. So that means it's going to be, that's what gives you that hint that it's going to be a horizontal shift. So it's going to shift left if c is greater than 0, and it's going to shift right if c is less than 0. This feels wrong. Everything that's done horizontally is going to feel a little backwards as we go through these. So don't let that mess you up. Kind of figure that out then. And if you have to, go back to one of the parent ones and plug in a real simple number like plus 1, x plus 1. Which way does that move it? And that will help you determine the left or right. Hi. So now let's do an example. I've given you a function here on the graph provided, and that function is f of x. We want to describe and graph g of x, and they've given us two transformations. So let's take a look at what those transformations are. This first one is going to be negative 3, so that's going to move it, shift it. This negative 3 will shift the graph to the right 3 units. Well, if I have a point negative 6, 2, or negative 6, negative 2, that means I am going to move that 6 3 units to the right. So it's going to become negative 3, negative 2. But I also have a point of plus 7, and that plus 7 is my vertical shift, and it's going to move it up. Shift up 7 units. So that means that this one is going to be added to 7, so I'm going to have negative 3, 5. So this point here gets shifted to negative 3, 5. 1, 2, 1. 2, 3, right there. Oops. I hate when it does that. There, right there. So that's going to be 1 point. Now I can shift those. So what my rule here was, I took whatever the x was and I subtracted -3. And I took whatever the y was and I added that C7. So for -1, 5, I'm going to subtract -3, which is like adding a 3. So 1 plus 3 is going to be 4. And -5 plus 7 is going to be 2. So that new point is going to be 4, 2, right there. And the 5, 1 is going to become, by adding 3, it's going to be 8. And then adding 7 to the 1 is going to be 8. So I'm going to have that point 8, 8. Right there. So let's draw a line here. And from here to there. And so, and whoops, I hate it when it does that. And let's call that G of X. All right, so that's our notes for today. I'll see you later. Good luck.